Good morning, everyone. We're going to be working on lesson 6 today. Now, today is going to look a little bit different because I don't exactly like the way that Eureka teaches you about mean. So I'm going to break it down for you a lot more simply. I'm going to be using the data set that you can find in your lesson 6. I believe it's exercise 1. It says that suppose that Michelle asked 10 of her classmates for the number of hours that they usually sleep when there is school the next day. The numbers that she collects from those 10 classmates is 8, 10, 8, 8, 11, 11, 9, 8, 10, and 7. Now, when we're calculating the mean of a data set is the sum of all of the numbers divided by the total amount of numbers in the data set. So we already know that there are 10 numbers in the data set. The reason why we know that is because that's how many people she took this data from. So there are 10 numbers that we're going to have to divide by. Before we can do that, we need to add them all up together. So when we're adding 8 plus 10 plus 8 plus 8 plus 11 plus 11 plus 9 plus 8 plus 10 plus 7, we're going to get the first part that we're going to need to be doing. So that means that we're getting 90. The second step that we need to do is we need to divide by the number of numbers that there are. So just to clarify how I got the number 10, I'm going to count it all out for you. There are 10 data sets, so we need to take 90 divided by 10. The mean of our data set is 9. You're used to, when we do median, we order them from least to greatest, like this: 7, 8, 8, 8, 8, 9, 10, 10, 11, 11. You're used to ordering them from least to greatest, and then you cross them off until you get to the center. Now, if you have two numbers, you know that you had to add them together and divide by 2. You're calculating the mean when you have two numbers left. Now, it's not always divided by 2. It's divided by how many ever numbers you have. So in this scenario, when we added them all up, we got 90, and we're dividing by 10 because that's the number that we have. So when we look at it, our mean, first step, add all numbers in data set. Number 2 that you're going to do is you're going to divide by the total amount of numbers in the data set. It's really as simple as that. But before I can let you move on, I want to just talk about what this means in terms of Eureka and what this means in terms of an exit ticket and what it might look like on your homework in the language that you might hear. So the way that Eureka uses to describe it is they call it fair share, which means that regardless of whatever number, so if you have all of these numbers, you're going to want to make it so that every number gets the same amount. Fair share, meaning that you would end up getting them all to 9 by balancing them out, giving some of 11 to some of 8, some of 11 to some of 10, so that they all ended up at 9. That's the idea. So when we're looking at this, I'm going to just walk you through really quickly what it means in terms of your exit ticket. The first question on your exit ticket asked If a class of 27 students had a mean of 72 on a test, interpret the mean of 72 in a sense of fair share measure of the center of test scores, because mean is another way to determine the center. The only problem with calculating the mean is that it's not a good use when we have outliers. The reason being is if we're adding all these numbers up, and we have outliers, like if we had a number 20 and if we had a number 1, that skews our data and that changes what maybe a true center would be. So if you have extreme outliers, mean is not the correct center of data we want to use. Typically it would be median then. So if we were told that the mean score was a 72 on a test, that means that the average in the class was 72, the center of data was 72, and that means that if everyone in the class got a 72 or it balanced out, that's what the center of data would be. So now moving into this language of fair share. Fair share is done by looking at using kind of cubes. It says, suppose that your school soccer team had scored a mean of 2 goals in 5 games. So that's saying that every 5 game, or for all those 5 games, you scored 2 goals. That was our mean. So we want to balance it out. Draw a representation using cubes that displays that your school soccer team has scored a mean of 2 goals each in 5 games. Let 1 cube stand for 1 goal. So 1 cube equals 1 goal. And if our mean is 2 goals, it means that every 5 games we are scoring 2 goals. So I've drawn 2 cubes, 2 cubes, 2 cubes, 2 cubes, 2 cubes for a mean of 2. Mean of 2. But this also means that your data could have looked a lot different before you calculated the mean. Your data could have looked like, for game 1, you could have only scored 1 goal. Game 2, you could have scored 3 goals. Game 3, you could have scored no goals. Game 4, you could have scored 4 goals. And game 5, you could have scored 2 goals. So if this is game 1, 2, 3, 4, 5. I still have the same number of cubes. I still have the same number of games. That doesn't change. So if I have this is the same thing as doing 1 plus 3 plus 4 plus 2. Doing that math, that equals 10. And I'm going to divide that by the number of games. Your mean is 2. And that's what this picture representation is showing. It's showing that no matter whatever you actually scored in the game, your mean is 2. Okay? And then it says, draw a dot plot that displays that your school soccer team had scored a mean of 2 goals in every game. I'm just showing that in all of these goals that I could have scored, I scored only 2. I scored only 2 goals. That's my mean. So I have 5 dots, 1 for every game, to show that this is my mean. All right. For homework, I'm going to change it up just a little bit. For homework, I would like you, I would like you to keep your sheet for this and your exit ticket to help you on your notes. Your homework, you need to do 1A, 1B, and 5. I believe it's 5. Let me double check really quickly. 1A, yes, it's 5A and B. So 1A, 1B, 5A, 5B. Let me know if you need anything.